Hi, sir. This is T. Kushi from IDA, and my roll number is 37. And my topic for concept video for Java is explain how graphics are generated using AWT. So let us get into the introduction of this topic. The graphics class is the abstract superclass for all graphics contexts which allow an application to draw onto components that can be realized on various devices or onto off-screen images as well. A graphic object encapsulates all state information required for the basic rendering operations that Java supports. This information includes the following properties. The properties are as follows. The component object on which it is to be drawn, a translation origin for rendering and clipping coordinates, the current clip, the current color, the current font, the current logical pixel operation function, the current XOR alternation color. So these are the main components of constructing a graph or any image using AWT. So what is Java AWT? Graphs. Graphics is an abstract class provided by Java AWT, which is used to draw or paint on the components. So AW is nothing but Auto Window Toolkit. So graphic is an abstract class which is provided by AWT, and it is used to draw or paint on the components. It consists of various fields which hold information like components to be painted, font, color, XOR mode, etc., and methods that allow drawing various shapes on the GUI components. Graphics is an abstract class and thus cannot be initialized directly. Objects of its child class can be obtained in the following two ways. So these graphics are obtained from this is an abstract class. So these are obtained from Java AWT. So AWT is nothing but Auto Window Toolkit. So it consists of various fields. So in different forms, it stores its information. That is, its components are in what color it should be painted, its font size, XOR mode. So these are some of the components and methods like drawing various shapes in GUI components. So GUI means graphic unit interpretation. So graphics is an abstract class, so it cannot be initialized. So how should we initialize this? So using the objects, you are going to initialize the graphic class. So these graphic classes can be initialized in two ways. The first way is inside paint of or update of method. It is passed as an argument to paint and update methods and therefore can be accessed inside these methods. Paint off and update methods are present in the component class and thus can be overridden for the component to be painted. So the syntaxes are void paint graphics G or void paint graphics G. The second method is get graphics method. So this method is present in the component class and thus can be called on any component in order to get the graphics object for the component. Public graphs get graphs creates graphs context for the component. This method will return null if the component is currently not available or not displayable. So there is an important point which is to be noted here. Painting must be preferably done using the paint method. Graphics drawn via object obtained from getGraphs method are temporary and are lost when the component is repainted again. And drawing might happen right away, but repainting may take some time and therefore remove the effects of code done through getGraphs. So how will you declare these classes? So class declaration, it is declared as a public abstract class graphs and constructors used as graphics of. So these constructors are used to create objects. So in graphics, you have many class methods. So let us look at some of the important class methods and why are they needed or why are they used. So abstract void clear rectangle. So inputs you're giving us int x, int y, int width and int height. So it clears the specified rectangle by filling it with the background color of the current drawing surface. So this is used to clear the drawn rectangle by giving the four inputs. And next is abstract void clip rectangle. So here also it inserts the current clip with the specified rectangle. Abstract void copy area int x, int y, int width, int height, int dx, int dy. So copies an area of the component by distance specified by dx and dy. So it is used to copy the area. Next, abstract graphs creates a new graph object that is a copy of the graphs object. Next is graphics create int x, int y, int width, int z. So it creates a new graphic object based on this graphics object, but with a new translation and clip area. So based on the given measurements, a new graph is created. Next is abstract void dispose. Disposes of this graph's context and releases any system resources that it is using. Next is void draw 3D rectangle. So you're going to draw a 3D rectangle. So it helps in drawing a 3D highlighted outline of the specified rectangle. Next, abstract void draw arc. So draws the outline of a circular or elliptical arc covering the specified rectangle. Next one is void draw bytes. So draw the text given by the specified byte array using the graphics context, current font and color. Next is void draw characters. Draws the given text by the specified character array using the graphics context such as font and color. Next is abstract boolean draw image. Draws as much of the specified image as is currently available. And you have many types abstract boolean draw image. It does many works depending upon the inputs you give. So draws as much as a specified image as has already been scaled to fit inside the specified rectangle. So these are some of the Boolean abstractions or graphs or class methods which are used to draw. Next is abstract void draw a line. So to draw a line, we will use this class method. So draws a line using the current color between the points x1 and y1 and x2, y2 in this graphic context coordinate system. Next is to draw a oval. You will use the syntax abstract void draw oval. So it helps in drawing an oval. And abstract void draw polygon. To draw a polygon, you are going to use this syntax or class method, and you will give the inputs, that is measurements. Next is you are having rectangular get clip bonds. Returns the bounding rectangle of the current clipping area. Rectangle get clip rectangle. It returns deprecated as of JDK version 1.1 replaced by get clip bounds. Abstract color gets this graph's context's current color. Abstract font get font. So it is used to retrieve the font. Font matrix get font matrix. It gets the font matrices of the current font. And abstract font matrices get the font matrices for the specified font. Next, void finalize. This is used to disperse the graphs after a long period of time. Abstract shape get clip gets the current clipping area, and abstract rectangle returns the bounding rectangle of the current clipping area, and rectangle get clip bounds. It returns the bounding rectangle of the current clipping area. So now let us see, still now we have seen some of the important class methods which are used to draw graphs. You have seen many things like how to draw a rectangle, how to find the area, how to change the color, font, how to draw the boundaries, how to draw 3D images. For all that, you have known the class methods with its syntaxes and uses. So now let us see how this work. How will you work with the graphs? The AWT supports a rich assortment of graphs methods. All graphics are drawn relative to a window. This can be the main window of an applet, a child window of an applet, or a standalone application window. The origin of each window is at the top left corner and is 0, 0. Coordinates are specified in pixels. All output to a window takes place through a graphics context. A graphics context is encapsulated by the graphics class and is obtained in two ways. It is passed to an applet when one of its various methods such as paint or update of is called. It is returned by the getGraphics method component. However, the same techniques will apply to another window. The graphics class defines a number of drawing functions. Each shape can be drawn edge only or filled. Objects are drawn and filled in the currently selected graphics color, which is black by default. When graphics object is drawn that exceeds the dimensions of the window, output is automatically clipped. Let's take a look at several drawing methods. So first, we are going to draw a line. So lines are drawn by means of draw line method shown here. Void draw line int. So this is the syntax which we use to draw a line. So void draw line int start x, int start y, int end x, int end y. So starting x and y points, ending x and y points are given. And draw line of displays a line in the current drawing color that begins at the start x, start y, and ends at end x, end y. So here you can see the program. So you're going to first import java.awt, and you're also going to import java.applet, and you're going to create a public class line extends applet, and you're going to give the values g.drawLine of 0, 0. You're going to pass the values for the lines, that means measurement lines, and you're going to draw the lines. So this is of drawing lines. Next is how to draw rectangles. So the following methods of graphic classes are used to draw rectangles. So you have many methods to draw rectangles. First one is void draw rectangle, int x, int y, int width, int height. Next is void draw rounded rectangle. Here you are going to give int x, int y, int width, int height, int arc width, int arc height. And void fill rectangle, int x, int y, int width, int height. And void fill rounded rectangle. Here you are going to give int x, int y, int width, int height, int arc width, int arc height. So these are 4 different ways in which you can draw a rectangle. So here there is a program. So here in picture you can see you have drawn a rectangle. You have drawn a filled rectangle. You have drawn curved, rounded rectangle and rounded filled rectangle as well. You can see in the picture. So the program is as follows. Same way you're going to import java.awt package, and you're going to create a public class rectangles extends applet, and you're going to give the measurements, that is g.draw rectangle of g.fill rectangle of g.draw rounded rectangle of g.fill round rectangle. You're going to give the measurements whichever you need. In that, according to that measurements, you will get the output. So now let us see how to draw ellipse and circles. So to draw an ellipse, we use draw oval off. So to fill an ellipse, use fill oval off. So to draw oval off, and to fill an ellipse, you will use fill oval off. So the syntaxes are as follows: void draw oval off, int top, int left, int width, int height. Void fill oval off, int top, int left, int width, and int height. The ellipse is drawn within a bounding rectangle whose upper left corner is specified by top, left, and whose width and height are specified by width and height. To draw a circle, specify a square as the bounding rectangle. So first we'll go through the program, and in the sample output you can see how our ellipse and the circles drawn. So in the same way as the previous programs, you're going to import java.awt, you're going to import java.applet packages. You're going to create a public class which extends the applet, and you're going to give the measurements using the syntaxes as discussed below, that is g.draw oval off, and you're going to give the measurements which are all needed. And according to those measurements, the figures are drawn and the output is C. So now let us see how you are going to draw arcs. Arcs can be drawn with draw arc and fill arc methods. So there are 2 types again. So the syntaxes are void draw arc of int top, comma, int left, comma, int width, comma, int height, comma, int start angle, comma, int sweep angle. In the same way, you will also have syntax for void full arc. The arc is bounded by the rectangle whose upper left corner is specified by top, left, and whose width and height are specified by the width and height. The arc is drawn from the start angle through the angular distance specified by the sweep angle. Angles are specified in degrees. 0 degrees is on the horizontal at the 3 o'clock position. The arc is drawn counterclockwise if sweep angle is positive and clockwise if sweep angle is negative, then it is anti-clockwise. Therefore, to draw an arc for 12 o'clock to 6 o'clock, the start angle would be 90 and the sweep angle would be 180. So here is the program how to draw an arc. So in the same way, import java.awt, import java.applet and the class extends, and use the syntaxes which are discussed earlier, and give the measurements what are all required according to you. So according to the given measurements, you will see the output, you will see the figures or graphs or drawn figures of that particular shapes. So now let us see how to draw polygons. So it is possible to draw polygons using draw polygon off or fill polygon off. These are two methods. Here also you will have two syntaxes: void draw polygon of int x, comma int y, comma int num points; void full polygon int x, comma int y, comma int num of points. So the polygons endpoints are specified by the coordinate pairs contained within the x and y arrays. The number of points defined by x and y is specified by the number points. They are alternative forms of these methods in which the polygon is specified by a polygon object. So here is the program. In the same way I discussed before, you're going to import java.awt package. You're going to import the java.applet package. You're going to create a public class which extends the applet. You're going to give the measurements. And in this extra thing is that you're also going to give the num points. So int num is equal to 5. So depending upon the given measurements, you're going to get the figure of the polygon as you can see in the picture shown. So one is filled polygon, one is normal polygon. So thank you guys. I hope you understood how the graphs are drawn using AWT, that is Auto Window Toolkit. And we have discussed many things like how AWT is used in creating graphics and what are the class methods and how is it declared, what are the syntaxes and what are the programs. We have also discussed the programs related to drawing lines, drawing rectangles, drawing arcs, circles, polygons, etc. So hope you all understood this. Thank you so much.